This script is chapter of making semiconductor. The device of semiconductor is made by many structures, including transistors, diode, passive component, and interconnect lines, and composed of conductor, insulator, and semiconductor. Application is memory, logic circuits, microwave circuits, optoelectronic devices, displays, and sensors. Semiconductor made by silicon because these structures are abundant elements in Earth's crust. Bourret, the science engineer, called the number of transistors in a dense integrated circuit doubles approximately every 2 years. Here are development of Bourret's laws as the game machine. So semiconductors continue to evolve as much as this. The atom, the smallest unit of matter, has its own eigenvalue and function, and the inner equally spaced in the boundary condition. When hydrogen atoms are taken as an example, their energy increases as they get closer and overlap each other. When they enter a certain distance, the energy is buried and the electrons are divided into atoms, which enter each energy and they form a band. The conduction band is the minimum part of the band without electrons, and the valence band is the top part of the state where the electrons are full. The part between them is the part that should not have electrons. In other words, it is called band gap. Depending on how much the difference is, it can be divided into insulator, semiconductor, and metal. Crystalline states of solid include crystalline, polycrystalline, and amorphous. The mobility is divided according to the order listed here. In the case of the n-type semiconductor, the Fermi level is close to the conduction due to the increase in the number of the electrons due to the presence of the group 5 in the state filled with silicon. On the contrary, the p-type, it is in a state close to balance due to lack of electrons because holes are formed. This combination can be made of a PN diode, which means that the thermal equilibrium state is awesome on the assumption that the Fermi level is constant. Here, the potential barrier is lowered and higher depending on whether the bias are forward or reversed. This leads to an increase in the degree to which electrons and holes pass, which increases exponentially.